Hello everyone, my name is Ajara Aida Kamagati. I'm from University of Dallas. I'm doing my business in business analytics and I'm going to present my project fraud detection in automobile insurance claim. For the content, I have background, data sources, business question, analytical goals, data processing, analysis and analytical procedure, deliverable, and the last one we have question. Insurance fraud is any act of fraud that a person commits to collect money that does not belong to them. Automobile insurance get the most specified claim. People tend to deceive an insurance company with that the most. Faking death, collision, or a car theft to collect insurance money. This is like an example. Sometimes people also go as far as falsifying a police report to use for their claims, and this is wrong. Insurance fraud impact consumer by adding extra fees and the cost of consumer goods and services. It also leads insurance company to deny benefit that is due. I got my data set from Kaggle. The title on Kaggle is Fraud Detection in Insurance Claim. The data set has 39 variables. Below will be policy number, age, state, gender, incident type, and police report. If you want to see the rest of the variables, just click on the link below. The question I'm going to use for my analysis will be: does the police report availability help to reduce fraudulent claim? Which characteristics of claim are the best indicator of a potential fraudulent claim? Build a model to predict if a claim is a fraud or not. For my analytical goals, I will be doing a logistic regression with features selected by a method such as recursive feature elimination. LFE would determine which characteristics of a claim are the best indicator of the fraudulent claim. Create a various exploratory visualization to examine the difference in the dataset. Build a wage model to show the future wage and the prediction of the model. Data processing. First of all, I will load the data to Panda, clean the data because sometimes there's some stuff in the data that we don't need it, create a training and testing dataset, and produce descriptive summary. To start my project, I will import my dataset to Panda. I will remove the value that I don't need it. I will create a visualization to compare feature with the claim result. I will remove what I think is not useful for my prediction. I will split the dataset to into independent and dependent set. I will build a model, a logistic regression. Then I will use a recursive feature elimination to predict the selection of feature and get the prediction using the logistic regression. Deliverable data visualization. We have three graphs here. The first one is a fraud reported. The 75.3% represent the claim that are fraud, and the 24.7% represent the claim that are not fraud. The second one is incident type with incident severity. We have four types of incident. I was just trying to know the different type of incidents we have. The last one, incident type with incident city. This graph is just to explain the type of incident we have in the different city. Here we have two graphs. The first one is a different type of incident. Basically, I was just trying to know how many type of accident that have more claim. The four type of incidents we have, the first one is single vehicle collision. The second one is vehicle theft. The third one is multi vehicle collision, and the last one is the packet car. The second one So which one is the fraud? When is 0, it means that there is no fraud. When is 1, it means that there is the fraud. Here you can see that the single vehicle have the most claim. Here we have two graphs. Those two graphs are based on the fraud reported. The first one is based on hobbies. We have different type of hobbies: sleeping, reading, board game, golf, skydiving, movie, polo, and etc. But the person that played chess on my data set, based on my data set, are the person that claim a fraud. The second graph is based on state. Here we can see that New York have more claim, more than 200 claim, but the fraud is lower. But South Carolina's have lowest claim, but the frauds are a lot. So basically here I was just trying to know who do the claim, and I discovered that there's a female and male, and the percentage of female are higher than the percentage of men. Female have 55% and male have 46%. Down the last graph is just to know the relationship. We have husband, over relative, own child, unmarried, wife, not in family. That's the type of people that do the claim. I was just trying to know more about my data set. Here we have two type of graph. The first one is authority report. We have police, known, fire department, over, and ambulance. When is 0, it means that there is no fraud. When is 1, it means that there is fraud. For the second graph, we have the police report. Blue mean yes, and no is orange, sorry. So we can see here that when it's no, the fraud is higher. When it's yes, the fraud is lower. After plenty of research and analyzing, this is my result. This is the confusion matrix. A confusion matrix are used to visualize important predictive analysis like we call specificity, accuracy, and precision. Confusion metrics are useful because they give direct comparison of value like true positive, false positive, true negative, and false negative. Here we have 4 parts: 37, 26, and the last one. 37 is a true negative. It means that the prediction of the claim are not fraud, and the prediction also are frauding. 20 is a false positive. It means that the data set was not fraud as we predict. 6 is a false negative. It means that the data was a fraud, but we predict as non-fraud. And the last one is a true positive, which means that the data set was a fraud as we predict. This is the end of my presentation. If you have a question or comment, please put it below. Thank you. I hope you like it.